Hey guys, this is Mr. Millings, and today we're going to calculate a bunch of problems relating to pH, pOH, H plus concentration, and OH minus concentration. So whenever we work these types of problems out, it's important to have this little diagram in front of you in the calculator. This little diagram allows you to figure out problems where you're going from hydrogen ion concentration to pH, OH minus concentration to H plus, etc., etc. So if we use this diagram in the example problems that we're going to do, we should have no problem making these calculations. So let's jump right in here and take a look at a few examples. In this first example here, it says to calculate the pH of a solution that has an H plus concentration of 1.5 times 10 to the negative 6 moles per liter. So in this problem, this is the starting stuff. We know the H plus concentration is this right here, and we're asked to determine the pH of this solution. So in order to go from hydrogen ion concentration to pH, we simply take the negative log of the hydrogen ion concentration. So in this problem here, to get the pH, we will take the negative log of the H plus concentration, negative log of 1.5 times 10 to the negative 6. We'll get our calculator out, and if we use the correct number of sig figs, which is 2 sig figs here, we should end up with 5.8. So this solution has a pH of about 5.8, which would ultimately make this solution acidic. Let's take a look at another example. All right, in this problem here, it says to calculate the pOH. So we want to know what the pOH is when we have a solution that has an H plus concentration of this. So if you take a look at this problem right here, this is a two-step problem. We can either go this way and then down, or we can go down and then this way to figure out the pOH. Either way, you'll get the same answer. I'm going to go this way first, and then I'm going to do this last just because it's easier for me. So first thing we need to do is calculate the pH of this solution. To get the pH, we will take the negative log of the H plus concentration. If I take the negative log of 2.5 times 10 to the negative 8th and put this in my calculator, I will end up with a pH of 7.6. So this is the pH. This isn't the pOH like the question asked for. So now how do I go from pH to pOH? Well, it says right here I have to subtract the pH from 14 and I will get my pOH. So to get the pOH here, I will simply take 14 minus the pH. And in this problem here, the pH appears to be 7.6. Put this in our calculator and we get 6.4. All right, so the pOH of this solution is going to be 6.4. Let's take a look at another example. All right, in this third example, it says to calculate the hydrogen ion concentration. So we want to know the hydrogen ion concentration of a solution that has a pH of 2.4. So we know the pH is 2.4. We want to figure out the hydrogen ion concentration. And the way that we do that is to take 10 to the negative pH, or the inverse log. Okay, so in this problem here, to get the hydrogen ion concentration, I will take 10 to the negative pH, and this is 10 to the negative, it looks like 2.4. And now we'll put this in the calculator, and it looks like we're going to end up with a hydrogen ion concentration of 4.0 times 10 to the negative third moles per liter. Okay. If we use the correct number of sig figs and round to the 10th place, or make it 2 sig figs, there you go. All right, so a solution that has a pH of 2.4 has this concentration of hydrogen ions floating around in it. Let's take a look at another example. All right, in this example, it says to calculate the OH minus concentration of a solution that has a pOH of 12.2. So in this problem here, we're asked to calculate the OH minus concentration. We want to know what this is when we know the pOH is this right here. So this is the given quantity right here, and we want to figure out the pOH. So the way I do that is simply to take the inverse log of this and we'll get our answer. So in this problem here, to get the OH minus concentration, we take 10 to the negative pOH, which in this problem, the pOH is 12.2. So I'll take 10 to the negative 12.2. We'll put this in our calculator, and we should end up with a hydroxide ion concentration of 6.3 times 10 to the negative 13th moles per liter. All right, so if you have a solution that has a pH of 12.2, it's going to have a hydroxide ion concentration of 6.3 times 10 to the negative 13th moles per liter. Let's take a look at another example. All right, in this example, we have to calculate the OH minus concentration of a solution that has a pH of 3.5. So we know this right here is 3.5. We want to figure out the OH minus concentration. There's two ways to do this. We can go this way and then go this way, or we can go this way and then go this way. It's a two-step problem either way. I prefer this way and then this way. You can get the same answer by going this way. However, we're going to go this way to solve this problem. So in this problem here, the first thing that we're going to have to do is we're going to first have to calculate the pOH. To get the pOH, we take 14 minus the pH. So we'll take 14 minus 3.5, and we end up with a pOH of 10.5, it looks like. This is not our final answer. This just brings us to this step right here. It's 10.5, the pOH. We now need to figure out the hydroxide ion concentration, and the way that we're going to do that is to take 10 to the negative pOH, or 10 to the negative 10.5. We'll put this in our calculator, and we should end up with 3.2 times 10 to the negative 11th moles per liter. Okay, so if you have a solution that has a pH of 3.5, its hydroxide ion concentration will be 3.2 times 10 to the negative 11th moles per liter. Let's take a look at another example. All right, in this example, it says to calculate the H plus concentration. So we want to know the H plus concentration of a solution that has a pOH of 11.5. So the pOH here is 11.5. And we want to know the hydrogen ion concentration. This is a two-step problem. We can either go this way and then this way to get the answer, or we can go this way and then this way to get the answer. And once again, I like to go this way first and then this way to solve this problem. This is just a little bit easier. So the first thing we're going to do is first calculate the pH of this solution. To get the pH, I simply take 14 minus the pOH, which is 14 minus 11.5. And we end up with a pH of 2.5. This is not our final answer. That just brings us to this step right here. We now need to find the hydrogen ion concentration. So to get the hydrogen ion concentration, looks like I'm going to take 10 to the negative pH, which is 10 to the negative 2.5. We'll put this in our calculator and end up with 3.16 times 10 to the negative third power, it looks like, moles per liter. If we use the correct sig figs, there's 3 sig figs here, there's 3 sig figs in this answer as well. So a solution that has a pOH of 11.5 will have a hydrogen ion concentration of 3.16 times 10 to the negative third moles per liter. Let's take a look at one final example. All right, we're going to save the easiest one for last. It says to calculate the pOH, we want to know the pOH of a solution that has a pH of 6.2. So if this is 6.2, the solution has a pH of 6.2, we want to know what the pOH is. And so to get the pOH here, we'll simply take 14 minus the pH. So we'll take 14 minus 6.2, and we should end up with a pOH of 7.8. So if the pH of a solution is 6.2, the pOH is going to be 7.8. So I hope this was helpful.